Timothy, good morning, I'm Timothy Precella. It's not morning, but that's irrelevant. We're going to be discussing factoring today, and I think I'll begin all of this by reviewing something you know how to do. We were doing it last week, foiling out binomials. Suppose we had this, 5x minus 2 times 3x minus 4. Y'all know about the first, outer, inner, last. We were doing that last week with imaginary numbers. Let's see. 5x times 3x, that would give us 15x squared. That's first. Now, outer would be...
negative 20x.
Yeah. So, minus 20x. So I've done first, outer, inner is that?
6x.
And what about that last term?
Positive 8
Plus 8? Yeah, negative 4 times negative 2, positive 8. Now the last time we were doing this, we were working with imaginary numbers, and we'd replace the I squared with negative 1, but we're not doing that here. No i's, just x's. So the outer and inner terms we could combine together. So our answer would be 15x squared minus 26x. And what's that last number? A plus 8. So not anything new. I just want this to be in our head because I'm going to sort of try to justify something. You'll notice that the middle term we got by combining the outer and the inner term. Combine the outer and inner term to get the middle term. We do the same thing here on this one. 4x minus 3 times 2x plus 7. So, foiling it out, let's see. The first term, is that a
8x squared.
8x squared. Now I'll do the outer and inner in red. Let's see, that would be what?
28x.
28x.
Plus 28x.
And,
negative 6x.
okay.
Then it would be
Minus 6x. And then the last term,
negative 20.
okay. So let's combine the outer and inner terms, the two red terms. Let's see, what would we have? We'd have 8x squared.
Plus 22x.
And then 28 minus 6 is 22. Y'all agree? There's a plus 22x, and then we still have that minus 21. I'm going to say something you'll get sick of hearing me say. In algebra, you always, you do it one way, then you do it in reverse. That's what factoring is. What we've just done was foiling. Now we're going to start going backwards. Given this, go back to these two sets of parentheses. So some observations. This first term is formed by foiling out. Multiply those first terms. The middle term is formed from the outer and the inner.
So we can't properly gauge that until we know what the other two numbers are.
Yes. And then the last number is these last two terms. So imagine going backwards. We were going to start with these and go backwards to these parentheses. We're going to use a trial and error process. I'm not sure how else you've done factoring before at your previous math classes. There's another method that I won't do, but it involves taking the first number and multiplying it by the last number, and then rewriting everything with 4 terms, and then factor by grouping. If you don't recall doing that, great. Okay? That's not how I'll do it. So, and this trial and error process is also called reverse FOIL, because you're reversing the FOIL method. So if we're going to go backwards, starting here and going backwards, I'm going to make a little table to sort of help you figure out the signs here.
Even if you don't write down the other stuff, I'd write down this table.
And like a
help
lot
you
of
with-
stuff, it'll make sense once you know how to do it. Okay, sometimes we'll tell you stuff and you, what the heck does that mean? So it's sort of unfortunate that it might not make sense immediately, but in a little bit it will. If we were going to go backwards, start here and go back to the two parentheses, the first thing I like to do is look at the signs. What
Make sure they
sign
know
will
what
be
they
in the
mean by the
parentheses?
first, what you mean by the first
Okay,
sign
you're right.
and second sign.
If we started off with 15x squared minus 26x plus 8, I'm going to call this minus right here the first sign and the sign in front of the 8 the second sign. I'll always assume this first number is positive, and you might say, well, wait, what if it isn't? You'll see why that's a good assumption before this is all over. Like right here, on this one, I'm going to call this red plus the first sign, and the purple minus is the second sign. So when I talk about the second sign, it's these signs right here. The sign in front of what's called the constant. In algebra, if you just have a number with no variable attached to it, it's called a constant. If the second sign is plus, the factored form, that's the two sets of parentheses, are going to have two of the first sign. What the heck do I mean by that? Well, if we're going backwards, starting here and going backwards, what sort of numbers multiply together to give a positive 8? Well, either two positives or two negatives. How do you decide what you're going to have in these parentheses? Well, you look at the first sign. If this negative 26 had been a plus 26, then that would mean we would need a plus here and here. And you'll see that better once we actually start doing an example. If the second sign right here, in the negative 21, if that second sign is a minus,
The only way you can get a negative product is to have a negative multiplied by a positive. Notice here.
if these two numbers here had the same sign, there's no way it would have been a negative 21. It would have been a positive. The only way you'll have a negative 21 is if one of these numbers is positive and one of them's negative. So I'm going to write 1 plus and 1 minus. So the second sign is plus, 2 of the first sign. If the second sign is minus, 1 plus and 1 minus. If I'm going backwards, if that second sign is a plus, you have 2 of the first sign, I fill those signs in immediately. Why? Well, I know that there's 2 of the first.
When you see that plus right there, you know the parentheses will have 1 minus in the first one and 1 minus in the second. But when that second sign is a minus, you're going to have 1 of each, but you don't know where the plus is going to go and where the minus is going to go.
Does it go in the first set of parentheses or the second? So I'll wait to fill in the plus and the minus. And again, some of this is just my preference. One more column on the table to get the middle term from the outer and the inner. The outer and inner are what give you that middle term. On the first situation where the second sign is plus, you're adding the 20 and the 6 to get the 26. Whereas on the second one, the 28 and the 6, you're subtracting to get that middle term. Now, before we start doing any problem from the homework or examples, I want to do one just to try to illustrate what I'm saying on this chart. So here's EX, standing for example. X squared plus 5x plus 6. Is it clear what we're going to do? We're going to get two sets of parentheses that we can FOIL out and get x squared plus 5x plus 6. This is just reversing the FOIL process.
This is actually my favorite type because both of the signs are what?
Positive.
Okay.
If
The last sign's a plus.
If that second
Two of
sign's
the
a
first.
plus, two of the first. I'll cut you off, Tim. So notice, since I know they're both pluses, I can fill those in immediately. That's what I mean by that spot, immediately. I know they're both pluses. Now, what do y'all think I'm going to put here and here in the first two positions?
One.
Yeah, to get a
Yeah.
x squared. That's an x. It might look like a y, but x. Put x and x.
Notice the leading coefficient. What's the coefficient on that x squared? I don't see a number. What do you assume it is?
One.
1.
That's called a simple trinomial because these are the simple ones to factor. If the leading coefficient is a 1, then it's a lot easier, okay? We don't have that many of those, unfortunately, okay? But it's a simple trinomial.
Now, in the last position, I have to put numbers that multiply together to give us 6. So I'm thinking this through. What numbers multiply together to get us 6? Well, there's 1 times 6 and 2 times 3. Well, which pair of numbers should I try? This is trial and error. Let me see. What do y'all think I should try? A 1 and a 6 or a 2 and a 3? 2 and 3. If you add the 2 and 3, is that going to, if we FOIL this out now, are we going to wind up with what I have here? Well, we know for a fact we got an x squared. Now, looking at the outer and inner terms, we would have a 2x and a 3x. Do those add together to get 5x?
Yes.
Yeah. And then positive 2 times positive 3. There it is. So we have that one right. And now I'm going to do one more example that's going to look a lot like this one. All I'm doing is changing the second sign from a plus 6 to a minus 6. X squared plus 5x minus 6. Oh, why can't they all be this easy? Well, is it clear that I'm going to use the second line on my little table? Because the second sign is a minus now. So that means there's 1 plus and 1 minus. I don't know where the plus goes. Is it going to go in the first set of parentheses or the second? So I'm going to wait to fill those in. But I know what to do. Oh, is it clear that this is a minus? It looks like I've made a mark on there to make it a plus, and it shouldn't be.
Well, it looks like a minus to me.
Oh, okay. So what am I going to put here and here, the first spots? Well, x and x.
Simple trinomial. You know what the first thing has to be.
Then I think through. What numbers multiply together to give 6? 1 times 6, 2 times 3. 1 and 3? Did I hear 1 and 3? 1 and 6. Why are we doing 1 and 6? Well, if you put 2 and 3, those aren't going to subtract to get you that middle term. Let's try a 1 and a 6. let's see, 1x. These little marks I'm doing here are the outer and inner. I remember this time years ago, before most of y'all were born, well, 1992, a student said to me, a hostile student, I never have hostile students anymore, but I was young, he was a hostile student, and he said, you're just making these things work out. And the rest of the class sort of laughed, and I thought, how will I handle this? And I thought, oh, wow. I told him, that's a brilliant statement. You are exactly right. I am making these things work out. I'm going to remember this and tell my other classes. Little did he know, 30 years later, when I stand up here doing this factoring, I'm thinking of that student, wondering whatever happened to him. But he said, you're making these things work out. How am I going to make it work out so that I get a positive 5? Where does the plus go and where would the minus go? Put the minus here and the plus there. So we'd have a negative 1x and a plus 6x. Is that given a positive 5x?
Yes.
Yeah. Okay. Unfortunately, there's usually a number in front of the x squared. So that's going to make it a little bit more difficult and more possibilities, but there's something I want to mention right now. There should be no common factor other than 1 in the parentheses. What the heck do I mean by that? Well, let's see. If you were trying to factor something, (4x minus 10). Could you ever have that in one of the sets of parentheses? Well, look at the two numbers, the 4 and the 10. Is there some number other than 1 that divides into both of them?
Yeah.
What divides into both of those numbers? 2. You can't do that. In general, when you're foiling, you can never have 2 even numbers in it. What about this one? Here's one where it's not 2 even numbers. 6x plus 21. They're not both even, but 3 divides into both of them?
No.
You can never do that. Okay? No factors other than 1 inside the parentheses. So what if I had this? 8x minus 21. Is there a number other than 1 that divides into these? 1 is the only thing that divides into them. So that one would be okay. You might have that as an answer.
Part of it.
Part of an answer. So we're just going to sort of go through the homework, choosing some problems at random that demonstrate what I think, the best ones to demonstrate these. And so I think we'll start off with problem number... Let's do number 2.
Okay, number 2.
It would be kind of funny if they didn't let you do number 2 unless you did number 1.
Oh, yeah. Okay. Did you want to make that you'll blow that up a little, Tim, while I write it down? No. Oh, it's just control plus. Oh, okay. Okay, so this is problem number 2. 12x squared minus 19x. Is that a plus or a minus?
Minus.
Minus 21. Okay. We're going to get 2 sets of parentheses that we can FOIL out and get 12x squared minus 19x minus 21. I'm going to go ahead and write my 2 sets of parentheses. And
It's sure not as easy as those first 2 because it's just the next square. The only possibility is x times x. We don't have square.
Oh,
1 times 12, so 1x times 12x, or 2x times 6x, or what else? There's a third possibility. 3x times 4x.
let's see. Right now. Let's get on over. I've written the problem down. And on my table, I think it's this one where the second sign is minus. Yeah, the second sign is minus. The second sign is the negative in front of the 21. So we're going to have 1 plus and 1 minus, but we've got to wait to fill it in because we don't know where the plus goes and where the minus goes. So I'm just going to make a note. We have a plus and a minus. A plus and a minus. Now, here's start. Sometimes students do it without writing out all the pairs of numbers, but I like to write out those pairs. The numbers that multiply together to give 12. There's 1 times 12.
Probably start 1x and 12x.
2 times 6. Oh, I just write the numbers. 3 times 4. So, one of these pairs is going to go here with the x's. I'll put the x there and there. Now for 21, numbers that multiply together to give 21. Okay, 1 times 21 and 3 times 7. If you do enough of these, you eventually get the feeling that, or you get the impression that the numbers that are closest together are usually the ones that are going to work. If I had to guess, I would think the 3 and 4 are going to be the ones that work, not the 1 and 12, unless there's some huge number here. Okay? So it's really as the middle term. But I usually start with the numbers closest together. It's up to you. This is just a trial and error process. I'm going to try 3x and 4x. 3, 4. And I'm going to try to pair it with one of these. Let's see if we can, like that student said, make it work out. Can we make it work out with a 3 and 7? By making it work out, can we make it give us a negative 19x when we combine the outer and inner terms? Oh, okay. My brother has a good idea. Suggested. Okay, suppose I try like this. The 3 here.
Don't write this down.
And the 7 there.
That cannot possibly work.
What number other than 1 would divide into both of these numbers? 3. When I said earlier you could have 2 even numbers in the parentheses, I should have also made this note. You can't have 2 of the same numbers. You can't have a 3 and a 3. Because then 3 divides into them. So I don't even need to bother trying it like that with the 2 3's together. Let's try it like this. If I put the 7 there and the 3 over here. Are these 2 sets of parentheses okay? It's the only thing that divides into 3 and 7 of 1. What about 4 and 3? Yeah. So let's do this outer and inner. If we were foiling it out, the outer term would be 9x. And what about the inner term? Is that 28x? Now, going back to my little table, we're looking at the row where the second sign is minus. Can we subtract the outer and inner, the 28 and the 9? If we subtract those, can we get a 19?
Yes.
Yeah. In fact, we need a negative 19. So look closely at how I'm doing this. Negative 19x. Which one of these numbers, the 28 or the 9, would need to be negative? Okay, you make the bigger number negative, the smaller number positive. Negative 28 plus 19 is negative 9.
No,
Excuse me.
negative 28 plus 9.
Yeah, negative 28 plus 9 is negative 19. So what symbol should I put in front of the 7? A plus or a minus? Minus and plus? Okay. And now, this is something you can always check, and you'll know if you have it right. Foil it out and see. Do you get 12x squared minus 19x minus 21? So type these in without ever hitting a space key.
So, oh, by the way, notice when I'm typing it in, it's hard to tell the way I've blown it up so much. Hold on. Wait, let's see. You see there are two options here. One of them is factorable, and they want us to type the answer in there. A prime number is a number that can't be factored other than just one in itself. A prime trinomial, this is a trinomial, there are 3 terms. That's prime means that you can't write it as a product other than one in itself. Suppose you went through all the possibilities and none of them would give you back that 12x squared minus 19x minus 21, then you would check that option there. But this one, you could factor, and it factored as, okay.
Parentheses.
Oh, by the way, notice down here they have this parentheses here on the toolbar. There's a comma there also. That's intended for ordered pairs. When we start graphing, I would not use those parentheses there. If you want a parenthesis, just type the parenthesis from your keyboard. That's a 3x minus 7, right parentheses, then a left parenthesis.
Notice how he didn't hit a space or anything.
Plus 3, right parentheses, and any questions there? Any questions?
You'll sort of follow. It's just, how lucky do you get getting smaller numbers or figuring out the correct pair? There's no set pattern. I have my little patterns. Tim has his patterns and how he does it. Write out the numbers and start with the numbers that are closer together, unless that middle term is really big. If the middle term is a really big number, you might want to start with the numbers that are close. That are the 1 and 12. Yes, the ones that are the 2 numbers that are closest together on the number line are the ones most likely to work. That's why I chose the 3 and 4. It's just, they're consecutive numbers on the number line versus the 1 and 12 or the 2 and 6. But that's just most likely to work. There's no guarantee. You're never going to find that as a theorem in an algebra book. Okay? A theorem in an algebra book is something that's always true. Now, unfortunately, there'll be times maybe where you are using the 1 and 12 instead of the 3 and 4. Okay? Yes. There's a good time to start with the numbers closest together. That's how I do it. How about number 4? Let's do problem 4.
We should have mentioned this also. If you're comfortable with factoring, you have your own method you use to factor and reverse FOIL, what have you, then don't even listen to this. Just use the method that you're comfortable using for factoring.
20r squared plus 19r plus 3.
Oh, I love the looks of that. The signs in the parentheses.
Yeah. I always think it's easier if that second sign is plus. And again, this is just, my preference, what I think. You might think, oh no, it's easier if the second sign is minus. But, okay, why do I think this one's easier? The second sign is plus. So, what did we say if the second sign is plus? 2 of the first sign. What was that first sign? another plus, so we're going to put a plus here and there.
Oh, wait.
Wait. Yeah.
Oh, falling down on my jaw.
Second sign is plus, so 2 of the first. Now we write out the numbers that multiply together to give 20. I remember the semester the student told me when I was doing this, stop right there. How are you getting those numbers? And it was actually 12 that I was doing. She said she punched 12 into her calculator and it didn't give her those numbers. And I was like, oh my gosh. The rest of the students laughed and I was like, it's the multiplication tables. You gotta, how do you get these numbers here? You don't just punch a 12 into your calculator and it gives them to you. You just sort of have to know those multiplication tables. It's been a while since you've used the multiplication or done any of this multiplying. You might want to get the multiplication tables and study over them during this week. Now for the 3, what numbers am I going to write right there?
Oh, I like this.
1 and 3?
That's it.
That's it. There's no other possibility for 3. So you know what I'm going to do? I'm going to go ahead and fill in the 1 and the 3. And if you were me, which pair do you think I'm going to start with? I'm going to start with the 4 and 5. It's just my preference. It's not a golden rule or anything like that. But let me try it. I'll try let me see. I wonder which of these, I'm trying to figure out which of these green pens leak. 4R and 5R.
Green doesn't show that.
Yeah, it doesn't. I'm going to get rid of those green pens. Because some of them leak, I know, because my hand is always covered with green ink. Okay. Well, how do I know if that works? Well, let's do the little outer and inner marks. The outer, if you're foiling it out, would that be a 12R? And the inner is a 5R? Oh, darn. 5R and 12R does not give me a 19R. What does it give me? A 17R? Okay.
That's called trial and error. We still know the 1 and 3 is the only possibility.
And we know that there's got to be 2 pluses. 1 and 3. Well, let's try reversing the 5 and the 3.
No, the 5 and the 4.
And the 5 and the 4. Let's put the 5R here and the 4R there. Notice, none of these had any common factors. Now, have I made it work out? If I look at the outer and inner, what am I going to have here? I'll have a 4R and a 15R. Do those numbers add together to give me a 19R? Yeah. So I found it.
It's called trial and error because you try something, and if that doesn't work, you try something else.
Mm-hmm. Yeah, unfortunately, that's why it's called trial and error.
Now, the correct answer has to have the same thing inside the parentheses, but there's nothing magical about the way Tony put the 5R plus 1 first. He could have had the 4R plus 3 first, and then the 5R plus 1. The order of the parentheses does not matter. All that matters is that you have exactly the same thing inside the parentheses. My math lab would accept either the 5R plus 1 first, or it would accept the 4R plus 3 first. Is that clear?
It doesn't matter which one you type first. Here are the 2 right answers. 4R plus 3 has to be in one set of parentheses, 5R plus 1 in the other.
The order in which you type them in does not matter. So which one do you want me to type in first?
It makes me switch them.
Hmm?
It makes me switch them whenever I fill it in.
Oh,
Really? Well, I'm going to type in Tony wrote in a 5R plus 1, so 4R plus 3, right parenthesis, left parenthesis, 5R plus 1. The order should, as long as you have exactly the same thing inside the parentheses, the order in which you type them does not matter. Any questions there?
don't hit space keys. Hitting a space will cause all sorts of problems.
Did you verify that? That was one of the things I'd spoken to Eric about. They were going to work on it. So,
I mean, put in the spaces.
Did they haven't fixed that?
Well, I mean,
just don't press the space key, as the space bar, ever, on my lab. Any questions there? Okay. Oh,
look at number 5. There's something that I don't like about number 5. 8b squared minus 5 minus 39b.
And I want to point out something. That means that what letter's going to be inside your parentheses when you're typing your answer? I should have mentioned this with that R, but whatever letter they have here is the letter you have to have in those parentheses. I'll see people writing the problem down and just by habit putting an X, then they'll type an X in their answer and
It'll say wrong.
and it's not going to say you're using the wrong variable. So,
To switch over here.
yeah.
Now, there's something wrong with the way this problem is written. These polynomials, these algebraic expressions, should be written in what's called descending order. Notice, x squared, x, constant. R squared, R, constant.
I would say R squared, R to the first, no R.
Oh, okay. Here, it should be in the form b squared, then a b, and then no b. What am I trying to say? We better rewrite this problem as 8b squared, then write the minus 39b, and then the minus 5. So constant, the number that doesn't have a variable should be last, and the squared term should be first. So that's why I rewrote this problem. That's why I said there was something about it I didn't like. The way that minus 5 isn't written as the last one. Any questions on how I rewrote that? Oh gosh, the second sign is what? Negative, so that means 1 plus and 1 minus.
We can't fill it in yet. I sure like it when the second sign is a plus. If I ever became ruler of the world, I think that would be one of those things I'd mandate. All trinomials must end with a positive sign.
And that is
I'd
a very poor
outlaw
joke.
I'd outlaw all trinomials that have a minus sign at the end. That'd be one of the first things I did.
As ruler of the world. Oh,
Yes.
wow, Tim. You wouldn't suffer hunger or starvation.
No, I wouldn't. I don't think I'd be successful there, but I think I could get people to go along with that last sign always being a plus. I think people would agree, yes, that makes factoring trinomials easily. And I'd take a mathematician's approach to the world anyway.
Okay.
Preferably abstract algebra approach.
Okay, so the 1 and 5, I went ahead and filled it in. Why? Well, there's no other possibilities. Oh, let's see. Do we want to try the 2, 4, or the 1 and 8?
Hey, look at this.
This is something I mentioned earlier, or was trying to say. If that middle term is kind of big, you might want to go with the 1 and.
8 times 5 is 40. That number there is just 1 less than 40. So maybe you need an 8 and a 5 up here. You know you have the 5.
If you want to try the 2 and 4, 2R, 4R, or 4R, 2R, I think you're going to figure out that doesn't work. This is one of the ones where the 1 and 8, you see? But then I noticed, there's the middle term is bigger than everything else, the 8 and the 5. So I would try it like this. Let's try the 8b here, and the 1b, or I'll just say b, right there. Because since the second sign is minus, we want to be able to subtract these to get a negative 39b. So we have a 1b and a 40b. I can subtract those to get a 39. So how do I need to arrange the plus and minuses if I want a negative 39b? Okay, so I'd want the 40 negative, the 1 positive, so put a plus in front of the 1, and minus in front of the 5.
Positive 8b times a negative 5. Sure enough, that gives us the negative 40b. And then positive 1 times a b gives us a positive 1b. 1 minus 40, sure enough, that gives us a negative 39. Any questions?
So after I just finished saying, I always prefer to start with the numbers that are closest together. The very next one is 1 when no. Use the 1 and the 8 instead of the 2 and 4.
But it does a good job illustrating the way that you had said that if this number here in the middle is bigger than you're expecting, then you might want to try the 1 and the number. And that does it.
Well, let's make sure it's right. Patch it in.
Okay. Okay. Which one do y'all want me to type first? The 8b plus 1 or the b minus 5? It makes no difference. The 8b.
Wait, what did you try to do? Just b minus 5?
Now, I bet you it was the sign that was wrong, not the contents. I'm betting then maybe you had the signs inside wrong, because as long as they have the correct things inside the parentheses, the order does not matter. Let's see. Sure enough.
I mean, you guys were saying like a couple times like in the previous classes that even though you put in the correct answer, because it was in the way that they wanted.
Oh yeah, those complex numbers especially. They're changed. But here there's really no particular format. I mean, as long as you have the 2 sets of parentheses, there's no standard rule like A plus BI. That complex number stuff where all of a sudden everything has to be A plus BI. It didn't used to be like that, but there's no standard rule for these things.
In my own defense, I have to confess, I never factored and canceled and left it as a single fraction with an I.
Oh.
I would always, split it, but
Okay.
I guess I shouldn't have. I should have. What's the next one? I should
Move on to number 6.
6.
Okay. 10x squared minus 7x plus 11.
Okay, Tony, don't answer this. Y'all answer. Do we need to rewrite this one like the one we just finished?
Yes.
Let's go back to the
Right.
one we just finished. Here we had to rewrite it because the constant was at last, but here the constant's already last.
X squared, X constant.
No
No
X.
X. So I'll draw my 2 sets of parentheses.
Oh, this is the kind I like. The last sign's a plus, which means no what?
What's going to be in the parentheses? Is it a plus minus or 2 minuses?
Plus.
If the second sign is plus, what
Yeah.
sort of numbers multiply together to give a positive?
Either
Either
negative
plus-
and negative or positive and positive. What are you going to use? Wait, let me switch over.
Oh, yeah. My little table isn't even visible. If the second sign is plus, and it is, what are we going to have?
Two of the first.
Two of the
signs.
first.
So negative and negative.
So the second sign is plus, so we know minus and minus. Numbers that multiply together to give 11 is not many, just 1 times 11.
So that should be easy, just show that.
What about for 1 times 10 and 2 times 5? I'm going to go ahead and fill in the 1 times 11. And then it's just a matter, I'm going to start with the 2 and 5. If I can't get a negative 7x out of it, I'm going to reverse the 2 and 5. If that doesn't work, I'll try to the 1 and 10. If that doesn't work, I'll reverse the 10 and 1. So there's actually 4 pairs I'm going to try here. I'll try 2x and 5x. If at any time you realize, oh wait, that's not going to give me a negative 7x, then cross it out and try the other one. But I'll never move the 1 and 11. I'll just leave a 1 and 11. I'm going to try 2, 5. And if that doesn't work, 5, 2. But doesn't work, I mean, if I don't get a negative 7x. Am I going to get a negative 7x out of negative 5x? And what's this outer? Negative 22x?
No.
No. Okay, so that doesn't work. Minus 1, 11. I'm now reversing the 5x and the 2x to see if that'll give me a negative 7x. Oh, what do y'all think?
Definitely not.
Yeah, that 5x times negative 11, is that going to be a negative 55? There's just no way I'm going to get a negative 7x out of here.
Cross it out.
Uh-huh.
Do you consider prime?
Oh, this is going to be the prime one. But I haven't tried.
One
But
that
we
like
still
can't
have-
be so much confusion.
But we can definitely say that 2 and 5 is not going to work. But we still have 1 and 10 to try. So let's try 1 and 10.
So if you do this assignment today, then you can use the fact that everyone's number 6 is prime. If you're going to wait and do it, well,
You'll probably forget it by the
Yeah.
time.
Is this going to give me a negative 7x if I do that? Oh, out of inner stuff. Let me see. I'd have a negative 10x and a negative 11x. What are y'all thinking? Is that going to give me a negative 7x? No. So, I'm going to go ahead and list the last possible one, but
Doubtful.
some of you have already figured out, oh, this is not going to work out. So if I tried 10x and x. Oh, wow, what the heck is 10x times negative 11?
Negative 110.
10, okay.
So there's no way.
Yeah, you don't have to write out all of this as long as you figure out or decide, oh, it's not factorable. Okay? I saw on problem 5, it just wrote out not factorable. I think on this one, the option is prime. I'll say prime or not factorable. This depends on how whoever was writing the instructions. Back in the olden days, one person sat down, wrote a book. It ain't like that anymore. It's a whole slew of programmers writing these problems. One person might say prime, click prime, and check it. And then go back to number 5, because I think number 5, it didn't say prime as the option. It says not factorable. So it's just a matter of whoever's writing the problem, are they going to say prime or not factorable? And any questions there? There's a lot of thought going on up here during this stuff. Or a lot of work going on. What about number 8? Oh, I like number 8. Is it in the standard form? S squared, S constant? Yeah. So
I'd like it more if that last sign was a plus, but I guess I can't mention that.
Well, I mean, actually, this is one of those times when I say I like it, meaning it's a good example.
Yes, it is. I know what you're talking about. I know what it's going to illustrate.
You don't want to have the easiest problems possible as examples. Mm-hmm. Okay.
Okay, let me switch over.
The second sign is plus, so what are we going to have?
The second sign is minus.
Oh, I'm sorry. The second sign is minus. I'm staring right at it. I'm sorry about
You're
that.
just thinking about how I want them all to be pluses.
I guess the second sign is minus, so
Negative and a plus.
yes,
You should wait.
Yep. It's going to be a plus and a minus. I'll wait. Numbers that multiply together to give 2 or 1 times 2.
That's nice.
Numbers that multiply to give 20 or 1 times 20. 2 times 10.
4 times 5.
Notice how the middle term isn't like dramatically larger than the other two numbers. So I'm going to start, well, first of all, for the
first.
S squared, it's 1S and 2S.
Mm-hmm.
Now,
Question.
I was just going to say that looking at this, I kind of realized that for ones like this where one's positive and one's negative, and you're always going to be subtracting, an easier way to determine whether it's a prime or not is to, or possibly an easier way to do the question is to look at like the 1 and 20, the 2 and 10, 4 and 5, and subtract them to see if it makes the one in the middle.
but that's only true if there's not that number in the middle here. I mean, in
That
front.
number in front.
Okay.
I guess, yeah.
Now, I noticed something. There's one pair of possibilities here that we can just discard.
Yes, this is the reason I say this is a good example. That statement I said about no common factors. You cannot have a set of parentheses with 2 even numbers. With that in mind, if you look at these 3 pairs, one of these can't possibly work. The 2 and the 10. Because if you can't put a 2 here, and you can't put a 10. You can't have 2 even numbers. So when you're testing or trying to figure out, it's either the 4 and 5 that's going to work or the 1 and 20. I'm doubtful about that 1 and 20 because the middle number is so small. But if I'm going to try the 4 and 5, don't put the 4 with the 2.
If you put the 4 here, they're both divisible by 2, so that can't work.
So I'm going to try a 4 here and a 5 there. And let's look at the outer and inner. We'd have oh wow. I discovered 30 years ago that if you wanted a class to miss a problem, you use a S as a variable. You have no idea how many times S's become 5s. If you really want to mess them up, you have a problem that has S's in the answer and a 5. Can y'all tell my S's from my 5s? This looks like an 85 right here, and it's not. It's an 8S. And this looks like a 55 to me, but it's not. It's a 5S. Can I subtract those to get this middle term?
Yes, if the 4 was negative, if the 8 was negative.
Okay, so if the 8 were negative and the 5 were positive, that would get a negative 3S. So that would put a negative here and a plus there.
So the outer product, positive 1S times a positive 5, gives us the positive 5S. Negative 4 times positive 2S gives us the negative 8s.
Wow, looking at this, it looks like I see a negative 85 and a positive 55 and a negative 35. Okay? But it's a S, not a 5.
And we didn't program it. We didn't program this. Realize.
Did yours have an S also? Yes, okay, so maybe everyone's number 8 has an S in it. Sometimes they'll change the variables, but it just depends on how hard the programmer is working on the problem.
Mine went from like S to X to B to B, C to X.
All on number 8 or different problems?
Different problems.
Different
problems.
Okay, but your number 8 was an S?
No, it was a 8.
Oh, okay, you see that? So hopefully your number 8 won't have an S.
They put lots of S's for this because they know that you're like easy.
Oh,
Oh,
okay.
well, what do you want me to write first?
Oh, just write it the way I
or
have.
2s plus 5. It makes
S
no
minus
difference.
4.
Okay, s minus 4 I'll put first. And then 2s plus, what have I just done? Plus 5.
Now there, the type things, I can tell the S is from the 5.
Mm-hmm.
Now, before we do number 10,
Yeah.
we're skipping around. So, I'm going to define something. So, Tim, switch it over for me to... I'm defining the word quadratic. A quadratic equation. I'm not defining the word equation. Equation is anything that has an equal sign in it in the original statement of the problem. If you went back to problem number 8, let's look at number 8. Look at the original statement of the problem. Is there an equal sign there? No, you might put an equal sign in the answer down there, but not in the original statement of the problem. How does this, what we're about to do, differ? Tim, click on problem 10. But don't write that down yet. I'm going to... See, here on problem number 10, is there an equal sign?
Yes.
I remember years ago at a restaurant, a student was a waiter, not my student, and he said, "Do you teach math at Delmar?" We were both there, and I said, "Yeah." And he said, "Oh, I'm taking algebra, blah, 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 blah." And I said, "Oh, wow, okay, how are you liking it?" And he up and announced, "I'm liking it okay, except my teacher is an idiot." Immediately decide I got to disengage from this conversation because it's someone I know, it's someone I work with that he's talking about. But he went on to say, "That teacher I had is so stupid. He tells us we're supposed to study the instructions," and I started trying to take up for the teacher. Oh, wait, depending on the instruction, whether it says solve the equation, like number 10, or if you look back at number 8, factor completely. You see, if it says factor completely, your answer is going to be 2 sets of parentheses. On problem number 10, where it says solve an equation, our answers are just going to be numbers. They might be fractions, but just numbers, no parentheses. And so I tried to explain that to the student. He went away thinking, that idiot. He's another one of those people telling us to study the instructions. But a quadratic equation can be written in the form ax squared plus bx plus c equals 0. In other words, a quadratic equation must have an x squared term. If it must have an x squared term, then if we want this to be a formal definition, we have to make another statement. A cannot be what number? What's the one number that A can't be if there's going to be an x squared there?
1.
No, not 1.
0.
0. Okay?
0 times anything is 0. So if you have a 0x squared, there's no x squared.
Hey, and that's, what do you call an equation that has just an x and no x squared? It starts with an L. It's the first type of equation you solved way back in your very first algebra class. Linear. So we're going to see this semester, we're going to solve linear equations and quadratic equations. Okay? So,
Well, they can use the rational root test so we can solve higher order equations.
to solve a quadratic equation by factoring, we're going to have a little three-step process. One, and this first step is usually done for you. Write it in standard form. By standard form, I mean you've got to have the x squared x constant equals 0. Then, factor, like we were doing just then. So there's one extra step after factoring. Set each factor equal to 0 and isolate the variable.
Look back here. Notice when you're factoring a quadratic expression, a trinomial, 3 terms, the things you have in your parentheses are linear. You just have the variable. You don't have s squares or x squares appearing in those equations. You know how to solve linear equations, and if you don't remember, we'll remind you, okay? But you take something that's quadratic, you factor it so that you don't have that square appearing anymore, and then the only way a product can equal 0 is for one or more of the factors to be 0. You can't multiply two things, neither of which are 0, and get a product of 0. So if this thing's going to equal 0, either this factor has to equal 0 or the other factor equals 0. And with that in mind, let's look at number 10. If you know how to factor, then once you practice factoring, these solving of these equations will be quite painless.
2b squared plus 17v plus 35 equals 0. Instead of trial and error, some of you may have remembered something where you go 2 times 35 is 70. Then you rewrite the 70 as 7 times 10. Replace the 17 with a 7 and a 10 and factor by grouping. If you don't remember doing that, then now is not the time to learn it. Okay?
Hopefully, if you view an example, that's not what they do.
Oh, yeah, I haven't even looked to see. Well, I'm going to go ahead and write out my numbers that multiply together to give 2. Notice it's already in standard form. V squared, V constant equals 0. What numbers am I going to write for 35? 1 times 35 and... would it be 5 and 7? Y'all caught up? Draw my 2 sets of parentheses.
We know something nice about the signs inside those parentheses.
What are we going to have in here? The second sign is plus, so
2 pluses.
2 of the first, so plus and plus. And one of these, there's only one possibility, the 1 and 2. So I think I'm going to write it like this, 2v and v.
Oh, okay.
Or v and 2v, however you want to write it.
I always put this, but it doesn't matter.
What pair, I have a feeling the 1 and 35 are not going to work. 7 and 5? How should I arrange it?
Play it out in your head. I think you can figure it out without writing and write down the correct combination. Should I have the 7 here and the 5 here? Or should I have the 5 here and the 7 here to give me back 17v?
7 here? Well, let's try. I'm going to try 7 there and 5 here. And if that doesn't work, we'll reverse the 5 and 7. So we'd have a 7v and a 10v. Is that giving me the 17v? Have I factored it correctly? So now we have the new step. You don't just write these two sets of parentheses, okay? You write 2v plus 7. Your answers are just going to be two numbers. In fact, one of them is going to be a fraction and one of them is not going to be a fraction. So, isolating the variable. That's where you do the opposite operation, beginning with addition and subtraction. Somewhere along the way, this is like one of the very first things you did in an algebra class. How do I go about getting this v by itself right here? Okay. But I generally do the addition and subtraction before the division. There's nothing wrong with dividing by 2 first, but you might get more fractions than you want.
You'll pick up fractions.
I'm going to subtract 7. The opposite of adding 7 is subtracting 7. And then, so we have 2v equals negative 7. And now what are we going to do to get the v by itself? Say it again. Divide by 2. So we have one answer, negative 7 over 2. Don't write that as a decimal or a mixed number. Algebra rarely uses mixed numbers. So what I just did there was the opposite operation beginning with addition and subtraction. If someone told you to say something algebraic, you could say, to solve a linear equation, isolate the variable by performing the opposite operation to both sides of the equation, beginning with addition and subtraction. The opposite of adding 7 is subtracting 7. The opposite of multiplying by 2 is dividing by 2. Now, this one over here is easier to isolate. What would I do to get this v by itself? You guys subtract 5? As we do more and more of these, my habit is to start doing this.
It's called transposing terms. You take the term, you move it to the other side of the equal sign, but it changes the sign.
And I just draw that little arrow as we progress throughout the semester. Rather than every time writing minus 5, I'll just do that.
Take the 7, move it to the other side, and it comes a negative 7.
So we have a negative 7 over 2 and a negative 5, which we've got a...
Okay, any questions? We're going to go type in these answers. Notice they already have the v equals written for us. They want us to use a comma to separate the answers as needed. So I have I guess most of y'all are using the fraction hot button, but I wanted to point out, if you just have number over number, you can use that slash bar on your keyboard. Negative 7 divided by, look what it did.
The slash.
It gave me that slash created the fraction, and I put the 2 there.
Now be careful. A lot of times,
Is this what I want?
No.
I don't want that comma in the denominator. Tab over, or you can click with your mouse. Put the 5. Now, some programmers, here's what you want. You don't want
negative
that,
5.
Oh, negative 5. You're right.
You don't want that negative 5 in the bottom. Sometimes students will type negative 7 over 2 comma negative 5, leaving the comma and negative 5 in the bottom.
Now, for some problems, the programmers decided, okay, they're going to try to allow this, okay? So they may accept it with that comma right there. But when we get to the 5th assignment, I think it's the 5th assignment, where we're solving inequalities using interval notation, if you're putting that comma in the denominator, it is going to count it wrong. It won't tell you what's wrong with your answer, but it's going to count it wrong. Here, they may, just because this is the first time it's popped up, they may have been nice and programmed it to accept this. Let's see.
You see
yes, but don't do that. Get the comma out of the denominator, or else when we get to inequalities, you are going to have a lot of wrong answers.
Let's do number 12. Oh. Uh-oh. Number 12. Let me write this down, and y'all be thinking about why did I say uh-oh?
Notice it says it's
Yes,
going to need to be rewritten, and it says solve. That's an equation. Notice they want the answer to be numbers,
I think
like the previous one.
in a previous semester I had some students that did really poorly on the first quiz, and it took me a while to figure out what the heck, why are these students missing these problems?
Every time it said to solve, to
factor?
factor, just plain factor, they were solving it like equations.
Once they got to this point, they set it to 0 and got numbers like +5 and -1 over 8. So that student that said, that stupid teacher tells us to study the instruction, yeah, you've got to make sure if it says factor, your answer are 2 separate parentheses.
That's one thing that's nice about taking the test with MyLab. Notice how the instructions, what number are we doing? 12. Notice how the instructions, they're trying to tell you right there. V equals. That means you're getting it set equal to 0.
And it says use a comma to separate your answers.
If you're just factoring, when you're just factoring, do you have a comma in your answer? Look there. Is there
No.
a comma?
Mm-mm.
No. Okay.
No. Okay, so this one is not in standard form because the v square isn't first. So I'm just going to rewrite it as a v square plus 13v plus 40 equals 0. Sometimes when you're rewriting this, sometimes students will want to change the 13 to a negative. No. Those signs only change if you're moving them across the equal. The next example is going to demonstrate that. Oh, okay.
Squared variable, v, no variable, equals 0. If you're going to solve an equation by factoring, it must be set equal to 0.
So I'm just thinking about the numbers that multiply together to give 40. 1 times 40, 2 times 20, 5 times 8.
I think you skipped one.
I did, 4 and 10. Wow, how did I skip 4 and 10? Maybe I better study those multiplication tables.
Maybe.
Okay. No,
Oh, this is nice.
this is one of those where there's not a number in front of the squared term.
A simple trinomial, that means it's going to be a lot easier to factor it. Because
And
for v squared,
That's what you were getting at earlier when you said you could sort of look and tell. The second sign is plus, so 2 of the first. Put a V and a V. We need numbers that add together to give 13. The 5 and 8 are the ones that are going to do it.
With a simple trinomial, you can pick the correct pair without any trial and error to it. That's a plus, so that means you have to add the 2 numbers to give you a 13. If that had been a minus 40, you'd have to subtract the numbers to give you a 13. That would have been trying in that case.
Any questions with my factoring here? Because we still have one step. Set each one of these parentheses to 0 and isolate the V. And what are our 2 answers going to be? Let me ask this. Are we going to have any fractions here? No. The V by itself, subtract 5 from both sides, or, like I did, show the little arrow. I'm just moving the 5 over, changing the sign. And what about this one here? V equals -8. It doesn't matter which number you list first when you type them in. You're going to type in -5, comma, -8, or -8, comma, -5.
Order doesn't matter. I think I'll put the -8 first. The -8, comma, -5. Any
Got to
questions?
be in that standard form.
What if it's like a x squared or s squared plus number with S underneath or something.
So there's no constant?
There's no constant.
Then it's not a trinomial, so you wouldn't use reverse FOIL.
Is there one like that in this assignment? Which number?
Question 11 for 9, and it says S squared plus 8S equals 9.
Oh,
Oh,
wait a minute.
wait, it's not in standard form. Look at our number 11.
Did you have to
B squared.
make it a negative?
I think
Has
that
to be set
number 15
equal
is
to
also
0.
like this, and I was going to do that one.
You have to move that 27 over. If you're solving a quadratic equation, whether you're factoring or using the quadratic formula, you must have it set equal to 0, and then descending order on the left side.
Okay.
The square variable, variable to the first power, no variable.
See, you've got to have that standard form equals 0. So here on number 11, instead of a 27 right here, we need a 0. So how am I going to get a 0 there? Well, you could, these little arrows that I just drew mean subtract 27 from both sides. So we have b squared plus 6b minus 27 equals 0. Well, what sort of signs are we going to have? Yeah, the second sign is minus, so a plus and a minus. 1 times 27, and there's another pair. Is it 3 times 9? So I'm going to put a B here and a B here. You already said there's a plus and a minus, so I'll wait to figure out.
What do y'all think we should try? The 27 or
3 and 9?
9?
Mm-hmm. Yep. Now, how am I going to, again, like that student said, I'm making them work out. How am I going to make it work out to get a positive 6? Where will the plus sign need to be and where will the minus sign be? Positive 9, negative 3. Is that what I heard? That is exactly right. I have a 3b, 9b, to get a positive 6b. Sometimes students say, oh, I can get it faster than you are. And my answer is always the same thing. Your goal and mine are different. Your goal is to get the answer as quickly as possible. If I were trying to do that, that would be a mess up here, I think. My goal is to try to show my thought process. So,
Okay, what's this first solution going to be?
B equal, first meaning the first one I'll write down. There really is no order. B equals, is the answer going to be B equal positive 3 or negative 3? Uh-huh. And the other one, B equals, okay. So enter 3 and negative 9. That's a comma.
3, comma, negative 9.
And now, let's do 15. Most of your homework assignments had 15 problems. I thought this one was going to have 20, but it didn't. Okay. Let me write this one down. It's the last problem, so it has to be the hardest. 42t squared plus t equals 30. See, I was saying this one, in my opinion, is like the one we just finished.
Only miss.
Only messier, yeah. Why? Well, there's not a 0 on here on the right, so what are we going to have to do? Minus the 30, aren't we? So here's what we're going to be factoring. Oh, wow. 42t squared plus t minus 30 equals 0. Oh gosh. Second sign is minus, so that's going to be a plus and a minus. Let me just go ahead and write out the numbers that multiply together to give 42 and 30. Don't help me on this. 1 times 42, 2 times 21. Let's see, what's 42? I think 3 goes into there. 3 times what? Is that 14? And there's one more pair. Oh, wait, I told y'all don't help me. 6 times 7?
Why'd you tell him not to help you?
Just because earlier I messed up on the 4 and 10.
Oh.
Okay, so I was going to try to do it right this time.
One thing I noticed as I go through writing out the possibilities, I
Tim,
always start at
you haven't been
1.
writing today.
That's okay. Oh, no.
Your hand's hurting
No.
still? Okay.
I have a doctor's appointment that I'm going to have to be leaving for. My mind's on that.
1 times 30.
But here's what I was going to point out. Yeah, I always start with 1 and then a number, and then I start working myself bigger, okay? 2 goes evenly, 3, 6, then the next number after 6 is 7. Hey, I already have 7 written right there, so I've had to have gotten all the possibilities, okay? So, like 1 times 30, there's 2 times 15, and what's the next one?
3 times 10.
Does 4 divide evenly into 30?
No.
No, but 5 does 5 times.
6.
And the next number in the list that I would check is 6. I've already got it there, so I have to have all the pairs of factors written there. I don't know if I explained that well.
No, but it was consistent, Tim. Okay.
You know something? I'm looking at the size of this coefficient here in the middle. What's that number in front of T?
Just a 1.
A 1? So I don't think I'm going to be using 42 and 30. I think I would expect something a little bigger there than just a 1. If I were going to have to use 42 and 30.
I'm going to try to see maybe the 6 and 7 and the 5 and 6. That's just how I would do it. That's what I want to try first. I'm going to try 6t and 7t. By the way, the second sign is minus, so it's going to be a plus and a minus. That's why I haven't filled it in yet. Now, if the 5 and 6 are going to work, how should I arrange them? Could I put the 6 right here with the other 6? Say no. You can't have 2 of the same numbers in the same set of parentheses. Heck, if you had a 6 here and here, 2 would divide into both of them 3, and so would 6. So if it's going to work with the 5 and 6, it's going to have to be like that. I'm not saying it's going to work, but oh yes it is. Okay. No, this isn't that bad.
6 and 5 are only divisible by 1. They don't have any other common factors. 7 and 6 only divisible by 1.
So let's see. How do I need to arrange that plus and minus if I'm going to make this thing work out? A 35t, a 36t. I want a positive t. So let's think of that as a positive 1t. So would that mean a plus on the 36 and a minus on the 35? So let's see. Would I put a minus in front of the 5 and a plus in front of the 6?
Positive 6t times positive 6 gives us a positive 36t. Negative 5 times positive 7, that gives me the negative 35t. Negative 35 plus 36, sure enough, it gives me a positive 1t.
Now, this is
Are
one.
we finished?
No.
Are we finished with the problem? No. What do we have to do?
Oh, wait. Say 6t minus 5. Set each one of these to 0. And
Y'all tell me, for this equation here, what are we going to do first?
6t minus 5.
We put the one that doesn't have a variable and put it on the other side.
Okay, so move the 5 over. So that'll be 6t equals positive 5.
And
And then
5 by 6.
No. Okay. You're doing the opposite operation beginning with addition and subtraction. The opposite of subtracting 6 is adding, the opposite of subtracting 5 is adding 5. That's what puts the positive 5 over there. The opposite of multiplying by 6 is dividing by 6. What about over here? I think we're going to have 2 fractions as our answer. Oh, okay. So there's one of our 2 answers. Now,
so that's going to give us 70 equals
a negative 6.
I was waiting for them to answer.
Oh, okay.
And then, okay, over 7.
So negative 6 over 7. And a positive 5 over 6. Those are the 2 numbers we're going to type in as our answers.
Any questions there before I type them in? So it's 5, 6, and negative 6, 7. I come over here. 5, 6. Get out of that denominator before you type a comma. Even though they've changed it so that this first time you're typing fractions and commas, they've changed it so if you type the comma in the denominator, it's okay. But they don't change it the rest of the time. When it's time to write that interval notation, if you put a comma in a denominator, it's going to be counted wrong. And what was the other one?
Negative 6 over 7.
Is that what I wanted to type?
Yeah, that looks right. Were you asking me or them?
I was asking them.
Oh, okay.
Any questions there? Let's see what this number 13 is.
Oh.
I think we have time.
Okay, we'll do one more. No.
Oh, that's too easy. Let's do one.
Okay, 14. Okay, 10. Let's do one more and then we call it quits. 14c squared minus 33c plus 18 equals 0.
I'll do this.
Okay, so first of all, thinking about that switch over, thinking about that 14, that could be 1 times 14 or 2 times 7, I agree. And for 18, well, let's see, there's 1 times 18 or 2 times 9, 3 times 6. Now, 4 and 5 are between 3 and 6. 4 and 5 don't divide evenly into 18, so I've got all the possibilities. And I'm noticing something here. This middle term there, that seems bigger than the other 2. If I added 14 and 18, what would I get? 32? This is only 1 off. That middle term, 33. So this is one of those instances where I don't think I'm going to start with the 2, 7 and the 3, 6.
You're not?
No, I don't think so.
Okay.
Did y'all follow my logic? I'm going to try the 114 and the 118. Watch this not work. Hey, the last sign's a plus. I know something nice in the parentheses.
Both of them are negative.
Okay, so the second sign's a plus, so you have 2 of the first sign. So we don't have to wait around. We know what those signs are going to be. This and that. You know, I think you're right. The problem is, no matter what, because of the, it's just going to be 32,
It's
isn't
going to
it?
be 32, not a
Well,
33.
Tony's little rule that we were using, if the number's way off from these, try the ones. I don't think that's going to do it.
But my little rule about trying the numbers closest
14
together.
times 18 is going to be huge. 14 plus 18 gives me 32, not a 33. So my little thought to use 114 and 118
Maybe we better try the 2, 7 and the 3, 6.
I would try that.
You think so? Let's try 2C and 7C. If we're going to try the 3 and the 6, can I put the 6 here? If I put the 6 here, there's something wrong.
2, yeah, a common factor of 2.
Both of them are even numbers, both divisible by 2, so I can't put that 6 there. So if I'm going to use the 3 and the 6, I'll put the 3 here and the 6 here. Now let me ask you something. Do we have any common factors in the first set of parentheses other than 1? Is there any number that divides evenly into 2 and 3 other than 1? No. What about 7 and 6? No, so those forms are acceptable. Let's check. Okay, the outer and the inner. What's the outer product? Negative 12C. What's the inner product? Negative 21C. Negative 21 plus a negative 12, that gives us a negative 33C. Is that what we wanted? Yes. Are we through with the problem? No, we have to. We're not done yet. We have to take each factor. Am I getting? I guess I'll have fun.
Oh, yeah, that's
Okay.
fine.
Set the 2C minus 3 equal to 0, and the 7C minus 6 equal to 0. Okay, this first one, we get 2C equals. What are we going to have here on the right side? 3. Move that negative 3 over, it becomes a positive 3. And then?
Divide by 2, so it's C equals 3 over 2.
Okay, I agree. So 3 over 2 is my first solution that I found. This one, we're going to get 7C equals.
6.
Moving that negative 6 over, it becomes a positive 6, I agree, and then?
It turns into C equals 6 over 7.
So we over 7, the 7's cancel. So the second solution we found is 6 over 7.
3 over 2 and 6 over 7. Separate them with the comma. 3 over 2.
Put the comma down there and see if it's still accepting it.
Well, this is, it simply won't take that. Okay? All right. Sometimes get students sending me emails showing me their answer and it counted it wrong, and I'd be like, yes, it's counting it wrong. Oops.
Let's see if it's still accepting it with the comma in the denominator. I think in this assignment it accepts all those answers if you put a comma in the denominator. But that is a very bad habit to get into.
Between the two.
The comma should be between the two. Type the fraction, then I use a right arrow. Some click with the mouse. I just use a right arrow, hit the right arrow, type the comma. Any questions there?
Now, let's see. So, the next time we're going to continue. You're probably sitting there thinking, well, wait a minute. You said not all polynomials are factorable. So what would we do if it doesn't factor? I know that's what you're thinking. We'll answer that question on Thursday.
Solving equations by factoring doesn't always work. If it can't be factored, then you can't use this method.
Those problems that there in this assignment.
Starting at number 10, they're all factorable. If they say solve by factoring, they're factorable, okay? Okay.
So I'm going to go ahead and stop